Hi, everyone. Thank you so much for watching. So the last question that I did for relative motion got some pretty good feedback. So I decided to do a few more relative motion questions, also because I remember that back in high school, I used to struggle with these questions the most, the relative motion ones. So I think it'd be a good idea to go through a few of them. And I think that because I did so many projectile motion questions, there was sort of like a pattern. And I think doing a few relative motion questions, I can also establish a pattern and make solving these types of questions a little bit easier for you. Okay, so a little warning, this is my second time recording this video just because I think the first time my explanation was so confusing. But just to point your attention, this is one of the harder problems for relative motion, but I think if you can get through this one, then it'll be so much easier to understand the other like more simpler questions. Okay. Another thing is there are so many ways to solve relative motion questions, right? So if I had the opportunity, I could probably do an hour worth of tutorials just for one question, but just because there's so many different ways to think of these types of problems. And even in my last question, sorry, in the first time I was recording this video for this question, there was just so much, I kept jumping from this solution to that method, to that method, to that method. So hopefully I can narrow it down this time. I will try to bring your attention to a few different ways how we could solve this, but maybe I'll actually do like a part 1, 2, 3 for this question, just so that maybe you can see different ways to solve this problem. And there's so many different like permutations of what I can do. And as we solve this problem, I think you'll understand what I'm saying right now. It might be a little bit abstract and babbling. So I'm going to stop and I'm going to start with this question. Okay, so in a World Cup soccer match, Juan is running due north toward the goal with a speed of 8.00 meters per second relative to the ground. A teammate passes the ball to him. The ball has a speed of 12.0 meters per second and is moving in a direction 37 degrees east of north relative to the ground. What are the magnitude and direction of the ball's velocity relative to Juan? Okay. So the first thing that we can do with a relative motion question is draw a diagram, right? So our diagrams are going to be in the bird's eye view, right? So before in projectile motion, they used to be kind of like at the side. We would view them so that we would be standing and the motion would be happening in front of us as a projectile like this way, and we would be like right over here, right? So now it is going to be different because we're going to be drawing problems from a bird's eye view. So let's go ahead and do that. What we want to do is we want to draw a compass. I think that's the best thing to do. So we're going to start off with a compass like this, and north, east, south, west. And we're going to say that north is going to be positive and east is going to be positive, right? So I'm just going to have like a positive, positive, just to remind us. And then therefore south and west are going to be negative. Okay, so let's write down our knowns. So I'm going to try to color code this so it's a little bit easier for us. So we say that Juan, relative to the ground, is due north 8.00 meters per second. And when we do relative motion questions, it's good to write down, I like to use like this format to write down my velocities. So Juan relative to the ground, I should do capital J actually, doesn't really matter. Let's just do capital J. So 8.00 meters per second north. And then, oh, also I should mention, this is a textbook question from Young and Freedman's textbook. This is not my intellectual property, but the solution is. So I just want to make that clear in the video. Okay, back to the question. So then the ball relative to the ground is 12.0 meters per second. And then when we have our direction written as this, so 37 degrees east of north, I personally like to do north 37 degrees east, just because I think it's so much easier to think about and visualize in your head and draw it on to the compass than east of north. I think that's just a little bit wordy and confusing. Okay. And sorry, I said I would actually do this color coded. So let's just go back and rewrite that. So we have the ball relative to the ground is equal to 12.0 meters per second. north, 37 degrees east. Okay, and let's draw those both on this compass right over here. So let's say that this is going to be 8.00 meters per second, and yep, in the north direction. And then when we want to draw this, right, so north 37 degrees east, so let's say that's approximately 37 degrees, doesn't have to be to scale, just to get a good idea. We really just want to find out which quadrant it's on so that we can figure out what's positive and what's negative from the components, right? So in this case, we know that both the x and y are positive, right, because this is positive and this is positive. Of course, if it were like this, then we would know that both the x and y are negative. Okay. So 37 degrees east of north, and this is going to be 12.0 meters per second. Okay, and in this question, what are we trying to figure out? Magnitude and direction of the ball's velocity relative to Juan. So ball relative to Juan is what? We don't know. We're trying to figure that out. Okay, so I'm going to start off by saying that just starting off with the solution, or like defining the problem, thinking of the problem, we know that we have to use chain rule, but even using chain rule, there's a few different ways we can use this. So I'm going to briefly talk about two methods, but I'm only going to do one of them. So method one, and then method two. So in method one, we recognize that this is what we're looking for. So we're going to create an equation that'll give us this, right? So in chain rule, we know that there has to be something right over here. Oh, sorry, J, not ground. It has to be J. There has to be something right over here and right over here that are identical. And then that kind of like, I say this with like air quotes, but cancels out, right? That's just how chain rule works. So we want two identical things right over here. Well, the only identical thing it could possibly be is ground, because that's the only thing the question gives us. So it has to be ball relative to ground and then ground relative to Juan. If we add these two together, then we get ball relative to Juan. Now, wait a second. We have this, or sorry, we're trying to solve for this. We have this right over here, right? But this, we don't actually have that. I'll get to that in a second. I'll get to that when we get to our actual solution. Now, two, what's the other thing we could do? Now, the other thing we could do is we can use the information right over here, and we can see what equation naturally comes to be, and then isolate for this. Okay, so in this question, I'm noticing that we have ball relative to ground. We're given ball relative to Juan, or no, we need to solve for that. And then we're given Juan relative to ground. And of course, these sort of, again, air quotes cancel out, and then we're given ball relative to ground. Now, because we're trying to solve for this, what we would do is isolate for this. So BVJ is equal to BVG minus JVG. Okay, so we could either use this equation or we could use this equation. Personally, I think I'm going to do this equation for a few different reasons. One, I think it brings up a lot of like important concepts. And it's just like, it's sort of like the more difficult way, not gonna lie, because you have to think about it a little bit more. But I do think it's the faster way, and I do also think that it'll allow me the opportunity to show you a few different things about vectors. So I think it's just like a good learning opportunity. Okay, so I'm gonna go ahead and erase this method too. But part of me kind of wants to do like a part two to this video where I just solve this same question that way. I don't know if you want a part two, leave it in the comments or send me an email and I might do it. Or I'll see how you interact with this video or like this video if you want me to do a part two so that I can do another method of this same question. Okay, so with this question, okay, problem. We said GVJ, but we don't have that. We don't have this. But what we do have is JVG, right? So now here's the incredible thing about vectors. I don't know if this blows anyone else's mind, but personally, I think it's so cool that if you have like A relative to B, that is the exact same thing as negative of B relative to A. Okay? So this is just sort of a rule. And like just to help you like visualize that a little bit better, if you think about it, north is just negative south, right? So if someone tells you walk negative south, you're going to walk north. And if someone tells you to walk negative north, you're walking south, right? Because again, it kind of brings into this like what we define as positive and negative, right? But because north and south are on this same dimension, one is just the negative of the other. And the same really goes for like these types of questions too. So A VB is equal to minus BVA, which means that JVG is equal to negative GVJ, and vice versa. So negative JVG is equal to GVJ. Lots of G's and J's, so sorry if I mixed that up, but the writing is correct. Okay, so we solved this problem. So I'm going to erase this. So we don't have this problem anymore. Now, again, this is going to require a little bit thinking, but okay. So this is going to require a little bit thinking, but we know that, according to algebra, when we have a positive, don't you agree that we can write it as negative? So if we have like, I don't know, like 4 plus 5, right? We can write that down as 4 minus negative 5. And these are equal to each other, right? So I actually write that next to each other. Right? These are equal to each other. So we can do the exact same thing with these vectors too. Right? Or let's, even better, didn't we say that, actually I should highlight it. I think that'll be so much easier. Didn't we say that this is right over here, right? So then why can't we use this and replace it? So what we can do is write down BVG minus JVG. And that'll give us BVJ. Now, all we have to do in this question is, solve this equation, or like add the components this way, according to this equation, or subtract, I guess. Then we have our solution. So let's go ahead and do that. Okay, so let's break everything down into X and Y. And I personally just like to draw out a little table just because it's a little bit easy. So if we have JVG, okay, what is the X component of that? There is no X component, so 0. I'm not going to draw a line because that's taking up so much space, but it's going to be 0. What about the Y component? Well, we said north is positive, so it's just going to be 8.00 meters per second, right? Okay, now what about BVG? We said, okay, so for X, it's going to be this component right over here. And that component, according to trig, is going to be 12 sine 37. And it's positive, right? So 12 sine 37. Okay, remember sine is the other line and then cos is close. What about for y? Well, we're going to have, it's also positive. It's going to be 12 cos 37, okay? Now, what we want is b, bj. In the x component, that's just going to be, what did we say? bvg minus jvg. So that's going to be 12 sine 37 minus 0. And this is going to be 12 cos 37 minus 8. Okay. So that we have, then we have our x component, our y component. And I went ahead and put this in my calculator. And I got 7.22178 meters per second here. And then for this one, I got 1.5836, and this one's just 9.5836 meters per second, just so that you can follow along and make sure that those are the numbers that you got as well. Okay, now the next thing we have to do is we recognize that we have our x component and we have our y component. And they're both positive, which means that they're going to be in like this quadrant right over here. So let me just go ahead and draw like another north and, well, I don't even have to draw north and east, but let's just draw our triangle. So it's going to be 7.22 this way. And it's going to be 1.5836 up, up in the up direction, positive direction. So we are going to find what angle is it, right? So then we know that this is going to be east and this is going to be north, right? And then we're also going to find out what is this resultant component as well, right? So Pythagorean theorem, if this is, it's going to be 1.5836 squared plus 7.22178 squared. And then we're going to square root that, and it's equal to, I'm getting 7.393368. Sorry, my handwriting is so hideous today. That's okay. I'm just going to make sure, just because I don't want to have to redo this problem again. Yeah, okay, so it's like 7.4 approximately, right? So 7.4 meters per second. Right, because we use Pythagorean theorem. And then what about this right over here, this angle? It's going to be tan inverse opposite over adjacent 1.5836 over 7.22178. And then the angle I get is 5.836 divided by 7.22178. That is going to be 12.37 degrees. So it's going to be east, 12.37 degrees north, right? Okay, so then our final answer, because we just solved for BVJ, is going to be 7.4 meters per second east, 12.37 degrees north. And that's our final solution. I know that was a little bit tricky, and I'm gonna try to do like a few more relative motion questions, maybe like an easier one too, just because maybe we can drill in the easier stuff, and then this harder question will make more sense to you later. But thank you so much for watching. As usual, if you have any questions, please feel free to send me an email or leave your question in the comments, and I'll get back to you as soon as I can. I hope this was helpful, and if it was, please don't forget to like and subscribe, and see you next time. Thank you so much for watching.